Hi, fellow sharpeners. Do you ever contemplate if your flat hone grit progression has any effect on the hair shear's cutting performance? Let's talk about that concept today. I'm Todd with Prairie Edge Service, and I recently found myself diving down a rabbit hole in my world of sharpening hair shears, and it was regarding my flat hone grit progression. Um, it all started from about 9 months ago. A barber came to me with a problem that his shears were pushing hair during the cut, and it was something that he hadn't really experienced with other sharpenings. Now, these shears had been sharpened by other sharpeners, and they had used a twice as sharp machine with the 120 grit wheel. And that got me to thinking maybe there's some merit to using a coarser grit on the outside edge, in sharpening that outside edge. So after some research, I decided to try something different with my grit progression process. My theory was that a coarser um, edge or coarser grit would produce a toothier edge, and that would help the shear grip the hair better, sort of like the same effect that serrations do on the old style barber shears. So what I set up to do was an experiment with the range of grits. So what I did is when I came to sharpening my shear, I would first sharpen the whole shear, apex it with 600 grit. Uh, and it would give a nice toothy edge for that tip or that point cutting technique at the tip. Then I would transition to an 800 grit, which I would sharpen through the majority of the shear, but leave the tip still at 600 grit. And this would now be a nicer, finer cut for blunt cutting. And then I'd transition to 1200 grit near the pivot for slide cutting. And this was to facilitate a dynamic edge, or the way that the shear would grip the hair throughout the extent of that blade. And it's the two blades. So stylists and barbers loved the results. They felt like they had more control, and I saw that they had improvements in how their shears cut, even in my testing with the hair. I could show them the slide cut region, I could show them the blunt cut region. Everything seemed great up until the last few months. When I come back for sharpening for them, some of the stylists came back saying their shears were pushing and folding the hair after 4 to 6 weeks of service. At first, I thought this might be just a few picky stylists, but I started getting multiple people. And in fact, in one salon, I had 50% of the stylists in one salon report that they were having problems. So this, in fact, became a wake-up call. Many said they had never had this problem before with previous sharpenings. So why was my sharpening so different? Something must not be right. I need to figure out what was really happening to these shears. So when I went to the one stylist and really gave good details about her experiences, she said that the shears were pushing the hair when she was doing blunt cuts, and then often would fold the hair at the tip when she's doing point cutting. And the other thing was that if she was doing backhand cuts for face frame, she would most of the time get the hair to fold every time through the blades. And she said this is extremely frustrating, trying to get the shears to cut these lines. And this told me I needed to get to the bottom of this. So I took the shear, took a much closer look at it. It was a lower quality shear. It was still sold by a beauty supply store, so it's not a cheap Amazon knockoff. But it's still not a top of the line shear. So that tells me the steel is a lower grade, so it might actually help me in understanding what's going on with the lower grade steel. So I started with the dry tissue test, and that test produced nice, clean, precise cuts. Next, I moved to the wet tissue test, and using a microscope, I check the results closely. Even under magnification, everything seems clean. There is some slight fuzziness as we get to the cuts near the very tip. Next, I test the shear with faux fur. Start with the fine hair because it's the most delicate, and the shear made clean cuts with no noticeable pushing. Then I moved to the thicker fur and saw similar results, only a slight amount of push at the very tip of the shear. Finally, I tested with real human hair doing dry cutting. The cuts were mostly clean and crisp, with a small amount of push at the tip, especially if I did it repeated and slowed the test down. Then I could actually see a little bit of push at the tip. So based on the primary testing regime that we have available to us, the shear passed all the usual checks. So that leaves me to wonder, if the shears are passing these tests, why are the stylists still unhappy? That's when I need to decide to take a much closer look under a microscope at the cutting edge itself. At first glance, everything seems fine. The outside edge remains fully convex with a nice crisp lines at the edge for the apex area. Flipping it over and taking a look at the ride line appears intact, and the cutting edge doesn't show any obvious nicks or damage to the edge apex either. But when I zoom in further, something catches my eye. There's a distinct polish wear pattern near the edge of the shear. So looking at this area under the microscope, I start to notice there are distinct wear patterns extending from the edge down into as far as 50% of the ride line. And we can see the bottom part, the original ride line, is still intact on the lower portion. I also see that the cutting edge remains nice and clean with no visible nicks or damage. However, the coarse sandpaper used in the sharpening may have appeared to leave nano-sized serrations, or maybe these serrations might be some part of the problem. And where these tiny serrations are, align with the wear patterns in the ride line. And it could be from either blade. So for me, this was sort of like almost like a breakthrough moment. When I was seeing the wear patterns extending into the edge of the ride line, the wear was actually removing metal from the inside of the ride line and causing a negative raked surface. So basically pushing the edge out away from the ride line. That got me to wondering, is the coarse edge on the apex causing a self-sharpening, where it's actually removing metal and causing a negative angle gap at the apex from the ride line? So if we take a look down the ride line, the blades are passing down the inside portion of the ride line, but because of the negative raked at apex at the tip, it might be the cause of the shears pushing the hair rather than cutting it cleanly for the shear, because we know that the ride line was fully apexed at the tip of it when I finished. So after all this testing, it turns out that the theory that I had been using, that a coarser grit for a toothier edge may appear to cause a self-sharpening action, that it's actually causing the blades to wear or remove metal right at the edge and resharpen an apex, but now there's a gap forming between the inside ride line and it's allowing a space to form. And I think that this is especially true for the types of shears that have a much finer or sharper angle. So something that is 40, 45, or 50 degree edge would be subject to the faster wear at the apex edge. And the problem also appears much faster in the lower quality shears, shears with a lower quality steel. So in the end, while the initial process works really great, over time the shears develop these wear patterns and it leads to pushing and folding the hair in a relatively short time period for some clients. As a result of these findings, I come to realize that a polished outside edge apex is better than a toothy outside edge. Therefore, I'm back to using a grit progression of 600, 800, and 1200 grit to define that outside edge grind along the entire blade again. Then I continue to my burr removal process by taking the shear to my 5000 grit whetstone, and I pull back to flip that burr back to the outside edge. I will typically add a couple of passes to create a smooth, polished, finished ride line all the way to that apex. And then I'll switch it back to the flat hone with a polishing pad, and I want to absolutely apply no pressure to the blade. The goal is just to make contact and whisk the flex burr off the entire blade. Because the burr started on the inside, then it was moved to the outside, the burr is now fractured and it's very easy to remove. This produces an extremely sharp and consistent edge along the entire blade. This whole experiment was a very valuable lesson and a reminder that even a small change to a sharpening technique can have unintended consequences. I hope this information may give you some insight that a toothy edge, while good for a knife, is not ideal for a hair shear, and that you may end up having more disadvantages than advantages regarding the performance with that shear. Again, I'm Todd with Prairie Edge Service. I'm wishing you all the best with respect to sharpening hair shears. Thank you, and see you in the next video.